In this movie, we'd like to examine three different types of motion graphs. We're going to look at a displacement time graph, we'll look at a velocity time graph, and then we'll finally look at acceleration time graph and kind of put them all together to see how they are related. So in this first graph, we're going to look at displacement time. So we'll put a displacement over here and a time over here. And of course, this is zero displacement, so this is a starting position, and up here is the positive part of the axis, and this is negative part of the axis. So this is going one way, and this is going the other. We could do up and down, or we could do right and left, or whatever. But we have a positive displacement and a negative displacement. And so we could graph various kinds of motion on here. If I have a straight line, you'd have something like this. And this would mean that you travel so many meters in so much time, and this would represent, the straight line would represent a constant velocity. We'd have a constant v, constant velocity. And to figure out what the velocity of that line would be, you would take the slope of this line. We know the slope is rise over run. That would be change in y over change in x, which in this case would be change in displacement over change in time, which we know is the equation for constant velocity. So here we have a straight line, and the steeper the line, the higher the constant velocity would be. So if I had another line in here like this, then this would be another car that would be traveling at a higher constant velocity. Whatever the slope of that line would be the constant velocity. So on a displacement time graph, we have a straight line, constant velocity. We know we're going in the positive direction here because we're going up the positive way. I could have had a straight line going down like this, and this just means that we're having a constant velocity in the negative direction. You'll notice we'd figure out our slope of this, and this would be a negative slope. It'd be a negative slope because it's going in the negative direction only. So you can have a negative velocity and a positive velocity. It just depends on which direction you're going. Okay, so we have so this is 0 and this is displacement. I didn't want to delete that each time. And I'll add a new layer in there to help me out here. Okay, so I could start out, I could have a constant velocity here, and then I could maybe have another constant velocity. And this is a slower velocity than this one is. And so right here at this point, right here, if we were going at a fast constant velocity and then we're going at a slower constant velocity, we see we have kind of a slight curve right here. And therefore, we would have a slowing down. This is an acceleration. A curve on a displacement time graph is acceleration. So I know I'm going at a fast velocity here, then I'm going at a slower velocity here, so I have a curve that I'm slowing down. I could slow down again and maybe go horizontal. And a horizontal line displacement time graph would mean that I've gotten this far away from home, and I'm still as far away from home. So actually, I'm not moving here. Velocity here would equal 0. And that should make sense because the slope, the steeper the slope, the faster it's going. And so the less steepness the slope, the slower it's going. And if I have a horizontal slope, I might have a velocity of 0. We could curve and have a straight line down like this. That's supposed to be a straight line, but I'll kind of redo that here and try to make it a little bit better. Try to use my straight line tool, see if that'll work. Somewhat. Not bad. Okay, and so here I was going 0. Here I'm going a constant velocity because it's another straight line. Now you'll notice this is a negative velocity. Why is this a negative slope? Because it's going down. So it's going in the negative direction. Remember, it's negative down here, and it's positive up here. So I'm going down the opposite way. So what I've done up here is I came to a velocity of 0. I stopped. And I've turned around and actually come back in the opposite direction. You'll notice here that up here I'm in the positive displacement location, but I have a negative velocity. I have a negative velocity because I've turned around and I'm going back the other way. So this curve right here would be an acceleration because I was going 0 and then I'm going some negative velocity. So therefore I'm actually speeding up. I'm just speeding up in the negative direction. And then I get down here and right at this point here, I'm on the x-axis, which means I'm back at the same location I was, but I go right on by my house. And I continue on. Now I'm on the negative side of my house, negative displacement, and I'm still going at a negative velocity because I'm going in this opposite direction here. And then I could slow down and stop. And because I would be going a horizontal line, that would be stopped again, a velocity equals 0. And then I could turn around again and go back up, and I'd have another positive slope. So I'd have a positive velocity. It means I'm going back in the positive direction again. So this is a displacement time graph. And one thing that we'll point out again is that we can have a curve. If I had a curve like this, that's an acceleration. And I think that should make sense. And we'll talk a lot about this later when we get to the calculus part of the lecture. But if I'm continuously accelerating, my velocity is continuously changing, which means I'm not going to have a straight line. I'm going to have ever increasing slopes of little straight lines. So I could take little lines that are tangent to the curve, and so right down here I'd have a line there, and then a line there, and a line there, and a line there, and a line there, and a line there. And you'll notice that each of these straight lines are getting more and more steep. And they're all doing this real fast so that we have a nice smooth curve. So a curved line is just a continuous changing of straight velocity lines. So this is the displacement time graph. All right, let's look at a velocity time graph here. And let's see. Let's see. I don't remember what I did there to erase that. But oh well. So we don't want this anymore. We want velocity time graph. I think it's probably down here. There it is. Okay. And we'll go here, erase this. Sorry about this. Okay, there we go. And so now we're going to have a velocity. So this is going to be a velocity time graph. And here is 0 velocity. And we'll still have this be the plus direction and minus direction. And we could start out with a straight line again. But these things are all going to be different now on a different graph. So on a velocity time graph, we have a straight line. And what would that be? Well, it would be, it mean we're going faster and faster and faster and faster every single second. So this would be an acceleration here. And again, if I want to do rise over run, here's my rise and here's my run. I do my rise over my run, I'm going to have change in v over change in t, which of course is acceleration. So the slope of a line on here would be an acceleration rate. Remember, a straight line on a displacement time graph was a constant velocity. On a velocity time graph, it's going to be a constant acceleration. Okay, so I'll have let's do this again here, and now let's go up to here. Let's do it that way. Okay, so if I have my, I could have a straight line, so I'm accelerating. And then maybe I could come up here and I could be going a straight horizontal line. What would a horizontal line be on a velocity time graph? Well, I could read over here and know exactly how fast I'm going. So this would be a constant velocity right here. A constant velocity on a displacement time graph is a straight line, but on this one, it's a horizontal line. I have a constant v here. And then I could have a line going back down, something like this. Okay, what would this possibly mean? Well, if I have a straight line, we know what a straight line here, what it was an acceleration, and this was a positive slope. a positive slope. And so I was going somewhere down here, velocity of 0 all the way up to some constant velocity. And I know this acceleration is positive, and because all of my velocities here are along here are also positive, they're up in the positive range. Because the velocity is positive, the velocities are positive, and the slope is also positive, since they're the same sign, we're actually speeding up. Whenever the signs are the same, for if the velocity and the acceleration signs are the same, that means both positive, or they could both be negative, then we are accelerating in that particular direction. But if they're opposite signs, if the velocity is positive and acceleration is negative, then we're going to be slowing down. So right here we have a negative slope. So our acceleration all along this line here is negative. So what does that mean we're doing from here to here? We have a negative acceleration, but I have a positive velocities. These are all up here in the positive area, up here in the top part of the quadrant. So they're all positive velocities, but I have a negative acceleration. Those are opposite signs, which means this car is slowing down, and that makes sense. It's going from a constant v here down to 0. But then what happens in the rest of the way? That's still a negative slope. It's a negative acceleration, but down here your velocities are negative. So this means we are going to slow down till we are stopped. We have a velocity of 0 here. And then we are going to be going in the negative direction. So we turn around here at the bottom here. The only place we can ever turn around is if we come and we actually stop and then go back in the opposite direction. So we right here at this x-axis here, we stopped and we turned around, and we are now accelerating or going faster in the negative direction. So here our velocities are negative, and here up here our velocities were positive, but the entire slope of this whole acceleration is negative. So this means that up here we're slowing down, but then on this part here we'd actually be speeding up in the negative direction. And then I could be going a constant velocity, and then maybe I could come back up. Now if I come back up, what does this mean? I have a positive slope, I have a positive acceleration, but I'm down here in the negative velocities. And so here would be a positive acceleration, negative velocities. This would mean I'm slowing down. So I'd have some negative velocity down here, like negative 30 meters per second or whatever this is. And then I'd be going negative 20 and then negative 10. And then I'd finally be up here, I'd be going 0 meters per second. So I'm actually slowing down. I'm getting less and less negative until I get to 0. And then I could keep going. I could keep accelerating here, and I have a positive acceleration, but here I'm in the positive, so I'd be going 0, and then I'd be going 10, and positive 10, 20, 30, and so my velocities would be positive, and so would my acceleration, and therefore I would be actually speeding up. So here I'd be slowing down, here I'd be speeding up. So it's very important to remember if velocity and acceleration vectors are the same, whether they're both plus or both minus, then you would be speeding up. If they're opposite, then you are slowing down. One more thing about this particular graph. Let's make a nice easy graph. Let's say and this will be for the future here. Let's say here's a graph. So what's this car doing? It's very easy. It's going at constant velocity. And let's say it does that for, we'll stop, we'll time it. We'll say, okay, right to this point right here. Okay, at this point here, whatever this is, 1, 2, 3, 4, 5, we'll just call it 10. Okay, even though it's probably not 10 seconds. Let's say this is 10, 20, 30, 40, about 50 meters per second. And so if this is 50 meters, if a car goes 50 meters per second, constant velocity for 10 seconds, how far does it go? And I think that makes sense. 50 meters for every second for 10 seconds would be 500 meters. And if you realize what you did there, you took this side of there's a rectangle right here. We have a graph, and there's the area underneath the graph, and you took this side 10 times this side 50. So you actually figured out the area underneath the graph. And so it's interesting when I do this that the area underneath the graph on a velocity time graph is actually the displacement. It's actually how far we've traveled if we figure out the area underneath the graph. So even if I have some crazy graph like this or something, velocity time graph, if I figure out the area underneath this, and that would be hard because I have a triangle and another triangle and a rectangle and a skinny triangle and especially if we have a curve, it's really going to be kind of hard, infinite little triangles here. But if I can figure out all the area inside this graph, I would know the displacement that I've actually traveled. That's called the integral, or integrating the curve. That's some more calculus, which we might talk about later. Okay, last thing I want to look at then is an acceleration time graph, which is pretty easy. We're going to have we'll have acceleration over here, and here's 0 and still plus and minus, and I have time right here, and so I can have we could do an increasing line again, but that would mean we're changing our acceleration. That's called jerk, but we don't really want to kind of go in that far. We're just going to have like constant accelerations. I could have a constant acceleration, a straight line, which means I'm accelerating the whole time. I'd be going faster and faster and faster, and that's the positive direction. So on a velocity time graph, that would be like a positive slope. And then I could just drop all the way down here, and whoops, that's not very good. I could drop straight down, and then have a negative acceleration, and I could have maybe a less negative acceleration, and come up here and have a more positive acceleration. And so we're not going to do a lot of curves or changing lines here where we're actually changing our acceleration rate. We're talking about mostly constant accelerations. So I want to have for a certain various times have different constant accelerations on this. And of course, if I was traveling on a constant acceleration for a certain amount of time, if I found the area underneath these graphs, it would actually be like, for right here, it'd be the velocity that I was going at the end of that time. So I had a constant acceleration for this amount of time. If I took this the area of this graph under here, that it would tell me my final velocity that I'd be going after I found that, because this would be acceleration and this side would be time. I multiply those together and I have the area underneath that. So that's an acceleration time graph. So I want to look at one last thing here. Let's look at this. So we have motion of a car graphed on 3 different graphs. We have a displacement time graph here. This is a displacement time graph. Let's see, we're going to use a different color because that doesn't show up the greatest. Let's use this. So we have a displacement. We have a displacement time graph. We have a velocity time graph, and we have an acceleration time graph here. And if we just kind of break this down and look at things, you'll notice here on the displacement time graph we have a curve. And so what's a curve? This is where I want to kind of do a darker blue. We have a curve. And what is a curve? A curve is an acceleration. It's an ever-changing slope lines. So it's a acceleration here. So on a velocity time graph, that is a straight increasing line for a velocity time graph. And on an acceleration time graph, that means we're constantly accelerating. If our velocity is constantly going up, we have a constant acceleration. That's a horizontal line on acceleration time graph. So I think we see how this works. We have a curve, which becomes a straight line, which becomes a horizontal line on an acceleration time graph. So then what do we have next? Well, we have a straight line on a distance time graph. What does that mean? That means we have a constant velocity. We have a constant velocity right there. I'm having a hard time doing that, making that look nice. Try it here with the line tool if I can. Okay, and so we have a constant velocity there. So what's a constant velocity look like on a velocity time graph? It's of course a horizontal line, a constant velocity. I can just read what it is right here. On the distance time graph, it's a little harder. I have to figure out a slope of that line. But on a velocity time graph, I can just read what it is. And if I'm going constant velocity, that means I'm not accelerating at all. So where would that be on acceleration time graph? Of course, it would be on the x-axis. It would be 0. So then we have this big chunk here on distance time graph. Yeah, I see I have a big curve all the way around. So I have some kind of an acceleration here. You'll notice here that if I look at the slope, if I draw this as a whole continuous little slopes, I have a straight line, and I have a straight line. It's a little bit less steep. And then up here I have like a horizontal line. I'm not moving at all. I have zero velocity, and then I'd have negative velocities if I draw my straight line. So I had a positive velocity, I'm getting less and less. So I'm slowing down here as I go up the peak. And then I'm going zero, but then I'm going the opposite direction and my slope gets steeper. So I'd actually be speeding up here. So if I'm coming up here and I'm slowing down and I'm going in the positive direction, and I have my velocities are also positive, they're all positive slopes here, that means my acceleration must be negative because I'm slowing down. And then it stands to prove that my acceleration is still negative because here my velocities are pointing in the opposite direction. My velocities are now negative, and so my acceleration must be negative because I'm speeding up. My signs must be the same on the acceleration and the velocity. So as I'm going up here, my velocities are positive slopes, and I'm slowing down. I'm clearly slowing down. So my acceleration must be opposite sign, it must be negative. But here I'm speeding up. My slopes are getting steeper and steeper in the negative direction, and so since I'm speeding up, my acceleration must also be negative. So that means on the velocity time graph, the entire acceleration line is I'm going from a high velocity to a less, to eventually zero, to then a negative velocity, and to even a more negative velocity. And so on a velocity time graph, I have this nice straight line, which represents, of course, acceleration. If I figure out the slope of this line, it's going to be a negative slope. It's going to be a negative acceleration rate all the way down to here. And so I start off at some velocity up here, like 15, and then I'm down to 10, and eventually I get down to 0, where I'm up at the top here. And then I go down to, I'm going in the opposite direction. So I came up here and then I turned around and went the other way. And so now I'm down here in the negative zone. And of course, this is all a negative slope, a negative constant acceleration. So on the acceleration graph, it's a negative constant line. And then if we go back up here, you'll see that I curve again. I have a little curve right there, and I was going a negative pretty fast speed, and then my curves all kind of changed, and the slope became less and less and less until it becomes 0. So that must mean I am slowing down here. I'm slowing down. You'll see I'm going in the negative direction, which means if I'm slowing down, then my velocities are negative, my acceleration has to be positive along this. And so I would expect a positive slope on my velocity time, which of course is what I see right there, a positive slope. I have a positive acceleration, and that means on my acceleration graph I should have a constant positive acceleration, which I do. Until up here I am not going any closer or further away from home. That means I'm stopped. I have a 0 velocity, which of course on a velocity time graph is going to be at 0 velocity. And if I have a constant 0 velocity, I'm stopped. That means I have 0 acceleration, so I'd also be on the horizontal axis right there. So hopefully that's a bigger picture of how all three displacement time, velocity time, and acceleration time graphs go together.